So, hello everyone. Here me again. I'm going to call the next speaker. So let me just press the buttons because you're always pressing buttons. And here he is. Here he is, Ludovic. How are you?
I'm
Good
good.
morning.
Thank you. Good morning, everyone. Can you hear me well?
Yeah. So far so good. So here's Ludovic Toyson. Am I saying
Yes.
your name
You're
properly?
absolutely, you're absolutely correct. My name is Ludovic. You can call me Ludo if it's easier. It's shorter. Everybody call me like that. Ludo is fine as well.
Ludovic is very good. It's a great name, so better to say it in the entire name. So don't worry. So Ludovic is a CTO at NFQ. If you didn't notice already, with his backdrop, and is going to give us a talk. Let me just pull the slide. Yeah, I'm not doing this very well. And pressing this brand can be the host. Yeah. So he's going to show us his talk about a journey from Gitflow to trunk-based development. Really curious about why you're heading from Gitflow to this. Hopefully you're going to show us. Oh, shoot. Remove add. Where is he? Where is he? Where is he? Here he is. I'm really curious to see what you're going to present us. And so I will let you carry away. Let me just
Cool.
press
Thank you very much.
buttons and add it here. So I'm going to pop out. So no worry about me. If you need something, just call me. See you.
Cool. Good morning, everyone. I'm very glad to be with you today for a Dutch PHP conference. And today we are going to try to answer two questions. The first question we're going to try to answer is, how can we stop struggling with releases? How can we stop, this kind of like weird situation when we have to freeze the code, when no one can introduce any change just because we are preparing a release? And the second question, also because we are kind of like cool people, how can we start actually to deploy on Friday without freaking out? And actually, it's a very good introduction because today it's Friday, so we should be able to deploy on Friday without being afraid of anything. My name is Ludovic. Like mentioned before, I'm working for NFQ. We are a software development company located in various countries. I am myself talking to you right now from Vietnam, a beautiful country. And as you may have spotted with my accent, I'm also French. Okay? So usually when we start a project, it's a little bit like, this New Year resolution. When you start a project, you say, hey, let's try to do things in the correct way. Let's try to apply processes, structure. Let's try to not repeat the same mistake we did on the last project. And usually you come up with this kind of, resolution. And one of the decisions you are going to take usually is to define a branching strategy. How the team is going to cooperate, how they are going to handle changes in the software. When you do that, actually, you try to define how the team is going to introduce changes in the code repository. And when you take this decision, it usually affects three aspects. First, by choosing a branching strategy, you will de facto impact the way the team is collaborating, the workflows, the collaboration model. You will also impact the code stability because the branching model defines the way we accept changes in the software. How do we accept them? How do we check them? How do we validate them? So you impact as well the code stability. And finally, you will also impact the release management. How are we going to deploy the software? How are we going to organize the release? All of this is inheriting from the branching strategy decision that you take as part of your New Year's resolution. A very common branching model that is super popular, especially in the open source community, is Gitflow. In this model, I'm sure you are familiar with it, we usually work with different long-living branches. We have the master branch in green that nobody can actually work directly onto it, and which represents the stable version of the software. As a developer, if I want to work to introduce feature, I will work instead of the develop branch, the orange branch that you can see now. And I will open, for example, some feature branch, and from time to time, I will merge back to develop. If I want to release my software, I will need to use a different branch called release, from which I will pull the modification from the develop. if I want to fix a bug, I will as well introduce a new branch called hotfix, right? So here we can clearly see a path where we use long-living branches to isolate the code. Our purpose is to isolate different codes to live in parallel and to control the way we accept or refuse modification to this code base. As a side effect, some teams as well are using Gitflow as a deployment strategy. It means that, for example, we are managing different environments, production, staging, QA, and we are tempted to say, hey, look, I am working on my feature, and if I want the QA team to test, I will just merge my work in progress to this QA branch. And then it gets deployed to the QA environment. And then after it's got validated, I can deploy to staging. And for doing that, I will merge to staging before finally reaching the main branch, which is the production. You can already see that there is some limitations, but I will explain that in a couple of minutes. So here, just to summarize, when we do Gitflow, what actually do we do? We have a strong code isolation. We really want to have this separation in different contexts of the code base. And additionally, we want to have long-living branches. And in some cases, some teams, we may have branches per environment. So this kind of approach is very nice, especially when you start with a fairly small team, right? With one team, this is what we actually achieve. When we start a project, 5 developers, fairly small team. And actually, when we look at the numbers, it's kind of like acceptable. On average, it took us like 1 hour to prepare the release, to kind of like organize everything, to prepare the release notes, to check everything, to test properly, etc. On average, each release contains 50 changes, right? In terms of size, we are talking about like 50 commits on average, if I summarize. And by having this Gitflow approach, we were able to deploy every week, which is okay, right? It's kind of like enough for us. But of course, like in many product aspects, you get successful and then you start to increase the team. And the more you add people to the team, the slower you get to actually release, right? We move from 1 hour, and at the end, with like many more people, we were releasing less frequently. Each release took us much more time. Each release contained a lot of features, and we were a little bit like stuck, right? And here, the question that many people ask is like, hey, guys, what actually is happening? You have more people, but you deploy less frequently than before. How is that possible? What is actually happening? And a very good start to try to analyze what's going on is to listen to developers, right? We should always listen to developer story, because I think it's very interesting. We can really learn a lot. And some people say, hey, I need to solve the conflict to prepare the release, right? I need to fix something. I need to test again, because of course I have solved the conflict, but I need to make sure everything works properly. We have fixed something, but now we need to pull this hotfix and cherry pick to all extra branches. So we need to kind of like having this set in mind. We need to remind that somebody fixed something, and now we need to propagate this fix everywhere. And finally, sometimes we also need to revert some changes. So here, what do we have actually? We have a situation of merge hell. We have so many branches that lives concurrently. We have so many flows that are working in parallel. We have so many people that are working on different things that it gets very tricky to manage the changes in the software, because we have conflicts, because we don't have a lot of transparency about what other developers are doing. And clearly, we are in this situation of merge hell when we have someone in the team that becomes super, super strong at fixing everything, and he's the only one who can kind of like sort it out. And why do we have that? Because actually, when we do Gitflow, we don't do continuous integration. Continuous integration is not related to the tooling that you have. It's not because you have GitHub Actions, Jenkins, Circle CI, or GitLab CI that you are doing continuous integration. It is completely unrelated. Continuous integration is a little bit like what we see on this picture. We have everybody working on the same environment, on the same artifacts. Everybody on these pictures is working on the same car. They are changing features, introducing new features, but they are working on the same artifacts. When we do Gitflow, we're actually working on long-living branches, which means basically we delay the time when we will integrate the code together. We delay, and we can't have continuous integration when we do that, just because we have to wait a couple of days for everybody to see the modification and to accept this modification to be part of the source code, right? Other stories is like with this approach as well, we have a couple of developers that are waiting for each other, meaning, hey, I am the front-end guy and I'm waiting for the back-end guy and they have not finished the API, so I will start a new feature in the meantime. And you start to paralyze the work because, we are good professionals. The problem is that you start to multiply the branches that you have to manage, right? Additionally, some people have to wait for the QA to be available to test this feature, or they have to wait for the staging environment to be available, or they again have to wait for the DevOps to deploy their feature. So this kind of like story that we have at that time, and which created a lead time. This lead time is kind of like everybody is trying to walk, everybody is trying, just like on this picture, to drive, but they are kind of like blocked and waiting for each other. And the reason why is because when you use branching per environment, you actually don't do continuous deployment. When I have to merge to this QA branch, to this staging branch, to this production, I always have to manually fix some conflicts, to manually fix some aspects. And then I don't have continuous deployment. And again, continuous deployment, I think, is sometimes misunderstood. We constantly think that continuous deployment is about automation. But again, it's not the tool. It's about the way the team is cooperating to handle the change and deploy them to various environments. Okay? So the question that we may ask is like, okay, it's good. We understand what's going on. How can we solve that? How can we avoid that at every Git merge, we have this situation when we have to handle so many conflicts, when it gets really like annoying, right? And one way to do that, of course, is to simplify our branching model. It's to get rid of all this complexity, to manage different branches in parallel. One way to do that is to use Gitflow, which is different from Gitflow, right? In Gitflow, basically, we just have one main branch, master branch, trunk, you call it the way you like. And this branch is actually representing the single source of truth. Everybody is working on the master branch. The master branch should be reusable all the time. It means that your production is represented directly by your master branch. And if I want to introduce changes, I will open a dedicated branch, I will commit, and then I will submit a pull request, and then it will merge back to master. So here we already kind of like simplify the way because we don't have to manage so many branches in parallel, right? Another aspect, another strategy we can also do is trunk-based development, which is kind of similar, but is a little bit more strict in some way. So again, here we don't have many branches in parallel, we just have one that we call the main or the trunk. And on these branches, we will represent again the truth, the stable version of the software. And the trunk should be releasable all the time. The production equal the main branch. And we allow teams to actually open short-lived branch, meaning they can work on some features and they have to merge back. What do we mean by short-lived? It means like no longer than 1 day. It means that I am able to open a branch, work on something, but at the end of the day, I need to merge back to the main because I want to resolve conflicts earlier, because I want to bring transparency for the rest of the people regarding the change I introduced in the software. Okay, so basically in trunk-based development, every day we have to merge back to the master branch. There is some strategy because I guess you already have some questions. Okay, so to summarize, either we do trunk-based or GitHub flow, we do have a trunk, this main branch, that acts as a single source of truth. That is releasable all the time. It means that if the branch suddenly is broken, everybody has to fix it. This is the top priority. And we have a series of branches that are only short-living. We forbid any long-living branches. And in case we are doing trunk-based development, we need to merge back every day. Okay? The way we implement that is that basically every commit becomes a release. We need to shift the way we think because now we need to introduce very small and consistent changes. Every commit becomes a single release. Okay? We have short-living branch, right? 1 day max if we are using trunk-based development. And when we have unfinished work, we are going to use feature flag to wrap the code in these feature flags. Okay? A couple of recommendations. Of course, it's a very big change, right? When for years you have been told that the master was the holy grail, that nobody can touch it, and suddenly you can work directly on it, you have to support the development team to operate this shift, right? It's very important as well to discuss about story and commit size. What does it mean to have like small commits, small story? What does it mean to release to production from master? We need to kind of like support the shifting in the mindset of the engineering teams. The second aspect that is very crucial as well is to instrument and adapt code reviews. We need to abuse from pull request decoration to automate as many steps as we can. And additionally, we need also to adapt a little bit the code review rituals to become synchronous. So here, for example, pull request decoration means that we will delegate to the automation tool everything, right? We need to, the value of code review from the developer perspective should be focused on what provide values. For example, a developer, when he reviews the code, he should not speak about standards. We already have tool for doing that. He should focus on, hey, the feature that you introduced, does it make sense? Do we create some issue in the software? Is it simple enough? Can I read it? This is providing value, not coding standards, right? And second of all, the synchronous code review means that in some teams, you know, you open a pull request and you say, hey, please, guys, when you have like 5 minutes, please review my code. And 3 days later, still no one came to you, and basically you are kind of like stuck. So here as well, when we move to this kind of like approach, it's good as well to help the development team to have some rituals, maybe every day, you know, you will block the calendar for 1 hour, and every day people have to focus and to say, look, for this hour, I will review the code of my colleagues. And I think it helps as well to become more synchronous and to allow as well this kind of like approach. Otherwise, if you have to merge back every day, but nobody review your code, you're gonna stuck, okay? Finally, we need also, if we want to take this approach, to consolidate the build processes, right? We need to have a proper completeness in our testing suites, and we need the build to execute fast. If your build takes more than 15 minutes, this is going to be very hard to have this kind of like approach because, again, we need to merge back every day. If we have like 20 developers and they have to wait a long time to have this execution running, this is going to be like a strong issue, okay? So now in terms of benefits, when we move to that, it actually lowers completely the merging effort because you are constantly handling conflicts. Thanks to that, we were able as well to release much more frequently, to have more stable iteration, just because instead of releasing a series of features all together, every commit becomes a release. So every iteration is way, way smaller, and then you can easily roll back, fix, analyze what's going on. You don't have to play shell combs to understand where you are. So it's kind of like interesting. And finally, it also helped to foster a baby step approach, meaning by doing this approach of like baby steps, small commits, deploy directly, merge, continuously integrated, it helps completely people to think in a very different way. They stop needing to have the full feature before actually starting to delivering it. And then they start to think strategically, which is very, very good, okay? So now, a couple of minutes ago, I say, hey, look, you have to merge back every day if you do trunk-based development. But of course, we have some features that requires way more time than 1 day to finish. So how can we handle unfinished work? How can we do and handle that? And the way we can do that is by using feature flags. This is also called feature to gods. It's actually a concept in which you will have like a piece of code that will be wrapped around your unfinished feature, and you will be able to dynamically enable or disable it, okay? So if I give an example, I am a front-end engineer, and I'm working on this new component, the blue component. The backend team is not finished yet, so I will just wrap my component inside the feature flag, and later on, when the backend team will be ready, they will just like turn it on, work with this feature, test it, and then after we will do what we're going to do. We can also do that on the backend, right? I am working on a complex refactoring. I want to optimize the algorithm on the backend. I want to provide transparency to my team so they can see that I'm already touching some parts, and I want to reduce the effort to manage conflict, and I can also do that. I can also like wrap my piece of code that is in progress inside this feature flag, and nobody is going to be able to use it except me. We can also do that to actually target specific audience and run maybe some A/B testing. So for example, I'm living in Vietnam, and in Vietnam, we have an application called Grab, which is similar to Uber. And with this application, we can actually book a taxi. A couple of months ago, I was in a city called Da Nang in the middle of Vietnam. It's a very beautiful city with like the sea and very good food. And as I was booking a taxi, I realized that there was this notification on the app that's saying, hey, we are actually testing a feature because you are located in Da Nang. But if I was in a different city and I was ordering as well a taxi, I would not have seen this feature. This feature would have not been enabled for me. So feature flag can also be able to target specific audience, profile, device. Maybe we want to roll out this feature only for iPhone, Android. And maybe we want to target a specific country, a specific profile, specific user, permission. We can also use feature flag to actually test the feature on specific dedicated audience, right? So feature flag, basically, we are deploying non-ready feature to production, yes. It's a little bit like what we see on this picture, right? The road is not finished, but I can somehow still use it, and I don't take any risk. We don't block the traffic until the road is completely finished. So we start to find a way to still allow the software to introduce changes, right? The second aspect to remember is that feature flag, we need to be able to enable feature on runtime. It's not just an if in the code. I need to be able in a second to enable or disable this feature. We are talking about runtime, right? And finally, when we do feature flag, we are decoupling the deployment from the release. When I am using feature flag, I deploy to production every day. But maybe I'm not releasing to production every day because the release will be the time when I turn on the feature. So it means that I am able to deploy multiple times to production every day, but maybe I'm not releasing it, which also decouple the risk. And we have this kind of like aspect that is covered by feature flag. Okay? So how do we implement feature flag? We can use a custom implementation because at the end, it's not rocket science, right? It's basically a Boolean that is exposed by a service. So we can do that by a component in the databases. We can do that by variables, libraries. We can also use some SaaS solution that I list down here. Whether you want to choose one or the other, basically SaaS solution offer much more features and usually are more nicely integrated, especially for product team. When you have a product manager, product owner, they want to control what's going on. They want to have like advanced scenario. Probably the SaaS solution will be better. If you want to work deeply in the code with your tech team, probably like custom implementation, especially at the beginning, is something you would like to take a look at. Okay? So the nice thing as well with feature flag when you use SaaS solution is that you can connect that to your software development workflow. You can connect that to Jira, for example, and you are able to kind of like enable this feature flag or disable them directly connected to your tickets. And I think it's very nice because it allows as well to bring some transparency and to integrate the product team inside the development of the software, right? They don't depend on someone, please, can you deploy that? Please, can you enable it? They can just like, be part of what is happening, and I think it's great. Where to place feature flag? I think this is a question that many people ask. Should we place them in the user interface? Meaning I will kind of like hide the components or pages. On the API, I can play with the payload that is incoming or a specific endpoint. Directly in the business logic, right? I want to optimize a specific part of the backend code. Basically, it will depend on the use case you want to tackle, right? And usually, if you have it on the front end, you should also have it on the back end to have some consistency, right? Just to remember, in terms of security as well, you need to think about that. It's not because a feature is hidden that the endpoint cannot be exploited. So you need to consider as well some consistency between the back end and the front end. Security aspect is very important. Additionally, when you do feature flag, you are deploying a code to production. So it means that your feature flag needs to be tested. What is happening when the feature flag is enabled? What is happening when the feature flag is disabled? You need to test these cases and to validate that your feature flag strategy is actually rock solid before deploying that to production. We are still producing code that need to meet some standards. Okay? Feature flag can also go wrong. Despite we are good professional, despite we are testing them, despite they are documented, feature flag can go wrong. I think it's a very common case. 10 years ago, a US company that was actually working on the US stock exchange. So they implemented some dynamic trading algorithm, to make some dynamic orders based on the stock. They actually introduced a new feature because the regulation in the US was changing, and they implemented an algorithm that was able, to make some dynamic trade. They introduced a feature flag because they wanted to control the way it was working. And they actually did a very good work, right? It was tested, it was documented. They have a progressive rollout. The problem is that they introduced a very big issue that results to lose $500 million in 45 minutes. And why it happens? It's because actually they reuse an old feature flag. They reuse an old value of the feature flag to introduce this feature. And unfortunately, they forgot to deploy the code on one of the servers. Meaning, I think they have like 7 or 8 servers, and they deploy the code of like 90% of the machine, but the last machine did not receive the new version of the code. And of course, when they turn on the feature flag, an old version of the software starts to enable on the last server, which results in 45 minutes to lose almost $500 million. Of course, it's just like completely catastrophic. The company completely like lost all the cash in one day. They got bankrupt. And this is something that we need also to consider when we're implementing feature flags. Okay? So a couple of recommendations. When we are doing feature flag, we need to have them as little as possible. I believe that more than 15 to 20 feature flags, it starts to be very, very like complex to manage, at least at our level, right? We need to place them as high as possible. Nowhere we can have a combination of feature flag that integrates together, right? You need to place them as high as possible, and they need to cover a wide space. Additionally, they need to be battle tested. If there is no automated testing that is covering this part, you can forget about it. They need to be documented. Who is responsible for the feature flag? What is happening when we enable it? What is happening when we disable it? When is it going to be removed? Who is responsible for that? This is what we call documentation, right? We need to remove them at some point when we don't need them anymore. In our team, for example, we plan that 2 or 3 sprints ahead, we will have a new tickets that will consist in removing this feature flag, because this is very important to remove at some point this piece of code to really have a definite version of the software. And finally, we should never, never, never reuse them. Once we don't use them anymore, we just forget about them. We remove this value, we remove them. And then if we want to introduce a new feature flag, we will use a new value, a new behavior, a new state. So in terms of benefit, by using feature flag, we reduce drastically the cross-dependency between teams. We don't have anymore this situation when people have to wait for each other. The front-end guy, when he finishes his job, if the back-end guy is ready, it's okay. If the back-end guy is not ready, he will just wrap his code in a feature flag. He will merge back to the main. And a couple of hours or day later, when the backend guy is ready, he will pull the modification, enable dynamically the feature flag locally, work with that. And this is the way we kind of like reduce the cross-dependency between teams. When you do feature flag, you actually enable continuous integration. Why? Because everybody is working on a very, very similar code base. You reduce the delay that we had before when everybody has the same version of the software, which is very nice. Additionally, it helps to have a product research mindset, right? When we start to introduce feature flag, we had wonderful communication and wonderful message in the development teams. The discussion were very nice because people start to strategize. Maybe we don't need 100% of the feature to start to test a use case. Maybe we can hard code some feature. Maybe we can, tweak some aspects. And if it's working, then we will work on this feature again. We will make a proper implementation. If it's not working, we just get rid of that. And I think it's very nice for engineering team to be very connected to product strategy and to have this kind of like thinking as well. Now that we have spoke about that, you remember that I mentioned a little bit about issues when we have to wait for environments. You remember, like, hey, I want to deploy somewhere, but it takes time. And then basically, we have some productivity issue. And the way we addressed that was to introduce ephemeral environments. Just to recap the situation where we had before is like we have different teams because the teams scale. And suddenly you have like a series of environments to deploy somewhere, you have to merge to some branch. It's complicated. People have to wait for each other. They have to reserve resources. It's kind of like super complicated. And of course, it slowed down everybody to do their job, right? What we did actually was to reuse this strong-based approach to kind of like design a new way of providing testing capability for our teams. So if we come back to trunk-based development, we have basically this plane. And when people work on some modification, they have this short-lived branch. What if for each feature branch, we create an isolated environment? Meaning, as a developer, when I work on this branch, I can deploy an environment that represents all my modification and that is completely isolated from the rest, right? I will have my own version of the backend, my own version of the front end, my own cron job, my own queues, my own databases. And if my colleague is working on a second feature, again, he will have his own backend, front end, crons, queue, databases. And then we have this ephemeral environment that are isolated per branch and that represent only my modification. If I am introducing a new feature, I will only see my feature on this testing environment in isolation from the rest, right? The way we did that is, of course, to use Kubernetes, right? And Kubernetes is very nice for that because in Kubernetes, you have what we call namespaces. And namespaces basically allow you to have different isolation mechanisms. And for example, you can implement what we call multi-tenancy. It means that every feature will have his own namespaces in which we will deploy a set of containers, okay? And basically, I will build dynamically this feature environment and deploy them inside Kubernetes in different namespaces. I will also generate, for example, a URL that will allow me to access to my environment, okay? The convention that we used at that time was to use Jira ticket ID, right? We use Jira ticket ID and then everything matched together. One challenge that we have to build this environment is, of course, how do we orchestrate this building aspect, right? If I am working on feature one, I am the front-end guy. I introduce, for example, changes on the front-end, but I don't need any changes on the back-end. I am a back-end guy, and I am working on feature number 2, and I am introducing changes on the back-end. And also, I need to pull the changes from the front-end, right? So how do we solve this kind of like scenario when sometimes we have to pull changes from different repositories of code, or sometimes we just have to default? We have organized a series of like processes in Jenkins. This is the solution that we use to organize our CI process. And the way we do that is actually to pull the pull request name or the branch name and to use it as a convention, right? If I am working on feature 1, I will label my pull requests feature 1. And for example, if I am the backend guy, I will introduce my feature 1 branch on the backend. And if my colleague is working as well because the ticket requires to introduce some feature on the front end, he will also create a branch called feature 1. In case there is none, we will default to master, right? So in that case, we have the backend with a specific feature. The front end does not to be touched, doesn't need to change, so we will just default to master. And this way, we are able to dynamically build an environment that represents what I am working on currently. Okay. Another aspect that is interesting, we connected this process to our Jira board. Why? Because we didn't want our developers to spend time to trigger some processes. We wanted to have a very smooth expectation. So one way to do that was actually to basically connect to the Jira tickets. And whenever I am shifting my ticket from dev to tests, I will create dynamically an environment, right? I don't have to do anything. It will be triggered automatically. And a couple of minutes later, I will receive a notification in the Slack channel, and the Jira ticket will be documented with the URL that gives me access to my environment. I will do my work, and later I will move to ready columns, and then the environment will be destroyed automatically. I don't have to trigger any weird aspects It's very transparent. Anyone, even non-technical, can do that, which is very helpful when you have like product owner, product manager, QA that wants to work on tickets. They just have to transit the ticket. Of course, it can be very expensive, and one way to solve that is to use labels. In our case, some tickets, they don't need to have an environment because you are modifying something that is not visible, or you don't need to have like very strong processes. So we use some labels, and when we put the label on the ticket, this ticket will be triggered, will generate an environment, while some other tickets will not. When we do that, of course, we need to stay cost effective, right? Because suddenly you have like a super nice toy and the developer, they really like it. But of course, you need to be very careful in terms of like alerting thresholds. So for example, when we have an environment that runs more than 2 days, we send a Slack notification to the people to check. And if there is nothing that confirms, the day later, the environment will be destroyed, because otherwise you keep running in parallel a lot of like resources on the cluster, and then it's not very cost effective. The second aspect that we learn as well and that we did, which is super nice, when we deploy Ephemeral environment, actually the application is empty. You don't have any data. You don't have users, business objects, orders, PDF, whatever. You don't have actually the data that allow you to generate some value from your testing perspective. So at the beginning, we started to implement some mock data, some fake data, but it cost us a lot of time, and it was not very, very relevant. What we did instead is that today, every night, we are pulling the production data, the production databases. We are anonymizing all the records, all the email, phone, addresses, first name, last name, whatever. We take 20% of this export, and every feature environment that is created will actually use this sample to start and to be fresh with data, right? And what is super nice with this approach is that it allows us, for example, to have really like production-like environment, because we have business objects that represent what is happening on the system. We reduce the gap between the development team and the operation team, because suddenly the development team see how the system is used, what kind of data is used, what kind of like pattern do we have. It allows us, for example, to investigate much better than before some production incidents, right? When you have bugs and you are able to quickly reproduce what is happening, because sometimes the bugs come from the data consistency, links. So it's very, very useful for really having this ownership regarding like how do we test and how do we understand the application. Additionally, I highly recommend as well to do the self-service approach, this kind of like platform engineering approach that we took that consists in connecting the instantiation of the environment towards the Jira flow, because it's really help people to quickly onboard and use and shift the mindset toward this experimentation aspect. Okay. In terms of benefits, by using that, we were able to remove completely the bottleneck, right? You stop waiting for each other. As a consequence, you increase the ownership in the team, right? People stop waiting. They were saying, okay, I've done that. Now I'm going to deploy the environment. I will test it. I will solve that by myself, right? You stop waiting for each other. As a consequence as well, the transparency for the stakeholder increase. It means that before, it was taking some time, to get a demo environment ready. You have to wait a couple of hours, come back when it's ready. Now, in like 10 minutes, we have something that works, that represents the new feature, and then we can easily demo that. And stakeholders really appreciate it, because they can see directly what is going on and give feedback directly. And then it's also much more interesting than having back and forth. Additionally, later on, we came up with a full end-to-end test suites implemented, for example, with Selenium. And it was very, very easy to integrate, because Selenium is running, for example, every day, and then he will just trigger a feature environment, and then he will just execute the test suites. And basically, it was very easy to implement thanks to this ephemeral environment that we implemented. Okay? So to summarize, what we have done to kind of like help the team was to simplify the branching model. This is why we shift from Gitflow to trunk-based development. What we have done as well was to decouple releases by using feature flag. We also have used ephemeral testing environment to increase the team productivity and to remove some dependency. And finally, we have built some representative testing datasets that allow us to have consistent testing environments that also increase the ownership in the team. Okay. So to summarize, we move from this situation with like a release time of like 9 hours to finally being able to release like in 15 minutes. And each release introduce like 10 changes, very small releases that also help us to have more stable iteration. And we were able, by this approach, also to deploy almost 2 times per day. When we really look at the data, this is the number of deployment per month. Before, with Gitflow, and later on with trunk-based development. And basically, even if we were doing quite okay with Gitflow, by shifting to trunk-based development, we were able to deploy much more frequently to production. We were able up to 4 times to multiply the frequency of deployment, which is super nice. 1 week, for example, we were able to deploy 13 times. One day, we were able to deploy up to 6 times on that day. And among these deployments, only 7% got a defect rate, meaning on 100 deployments, only 7 contain a really blocking issue that was very easy to roll back or just to disable the feature flag. So it increased as well the stability of the software in terms of like deployment. Okay. So the challenge, of course, we need, if we want to go with this approach, to support the mindset of the engineering team, right? We need to rework what is the definition of ready, what is the story size. We need to constantly like act, work, and advocate for this approach. We need to encourage as well the ownership among developers. When you move from having some strong code isolation, when basically the responsibility to introduce the change is handled manually and suddenly everybody can work on one single branch, you have to encourage this ownership because otherwise people won't actually follow and buy this approach. When you do that, the team structure can also be affected. Probably you will work more with feature teams rather than component teams just because you have less isolation and you are working more on this feature stream rather than component stream. Couple of recommendations if you want to go this way. Support the adoption by using workshop. You need to talk and convince to a lot of people. You need to coach them to work in a very, very different way to remove some dependency. Stakeholders as well. They suddenly see that the features are deployed much quicker. They see that we are working faster, but it's not because the feature is working in production that the work is over. In 2 or 3 weeks, we will still need to work on this feature to improve it or to remove the feature flag. So it means that we have a quicker time to market, but possibly we will need to fix some solution at some point to improve it. So we also need to communicate this vision to the stakeholders. We need to constantly challenge the sprint planning, how to remove dependency, how to refine the scope of work, how can we work with small aspects. We need to monitor the trends as well, right? It's not because you do that you stop monitoring. You still constantly to investigate what is happening, to conduct retrospective, to identify where the lead time is. And we need to empower our developers by providing some guardrails, right? In our team, for example, everybody, no matter the role, the seniority they have to deploy to production at least 1 or 2 times every month because they have to feel confident in this action. They have to feel responsible. And surprisingly, but I'm not very surprised at the end, it's like they like it. Developers like to ship. They like to see what they are doing and how it provides value and how it impacts the work of others. So developers feel much happier when they see that the feature is going, they follow what is happening, and they see that their work is actually useful and that they have some impact on it, right? Couple of recommendations, 2 books that I really like about this approach that really help us to think about how we could move with that. The first one is Accelerate, very, very good book. And the second one is The Unicorn Project. Okay? Thank you very much for your attention. I think we have like, let's say 4 minutes for questions. I will be very happy to answer them. Otherwise, we can still Slack later. Thank you very much.
Impressive talk, man. Impressive talk. So thanks for that. and my mind's still blown away with your input. And yes, we got a couple of questions, and I got this comment that I need to say it out loud. So, from the chat, Robert Van Linden, he just mentioned every solution will create their own problems. So bravo for that, because we are developers, we know that thing very well. So a quick comment on that I spotted on the chat. So questions. First question is from me. I got a question. So what's your opinion about Git commit messages just having whip?
I think it's a good question, but basically, maybe I can stop here. I can stop sharing my screen. So basically, when you move to trunk-based development, there is no such work in progress because every commit becomes a single release. When you do something, you already achieve a result. So there is no properly work in progress. Despite you have not finished something, you already achieved something, a goal, and then there is not really like work in progress. You are always delivering something that matters. Okay, so even if the feature is not finished, you already changed something that everybody can see, that everybody can use, and this is the way we kind of like approach that. Not sure if I answer completely your question, but this is a little bit the philosophy we have in the team.
Yeah, because on Laravel we have like a whip comments, git commit message everywhere. So pretty much that it's a thing. But giving that segue, because if everything is being deployed, so everything is done, as you mentioned, what about, this is a question from, let me just get the name. So Andrew De Jong. Hopefully I'm properly saying the names. Sorry about that. So he's asking, and giving that segue, how about when you are fixing a bug? Sometimes fixing a bug takes longer than a day. So how do you manage a trunk-based development with that in mind?
Okay. So when you introduce trunk-based development, like I mentioned, when your work is not finished, you need to use most of the time feature flags because you have not finished, but you already produced something. The feature flag can be used when you touch something. Sometimes you can produce code that affects nothing, right? I can introduce code, but the impact is very, very like isolated. So the feature flag will help us to do that. When you work on some bug, or something that can impact a lot of things, you can still use sometimes long living branches. If you upgrade the framework, for example, for sure, it impacts basically everything. So it would make no sense to use the feature flag if you upgrade a framework or if you do massive change. So I don't know how to answer properly your questions. It depends again, right? If you touch many things that are crucial, then the feature flag will not help. Ideally, we should use feature flag when we have work in progress.
I really love that answer. It solves every problem. It depends. It depends on the case.
We will be full if there was like a silver bullet, of course.
Yeah, but it will always work. Because we all know that it depends in every case.
Yeah.
So another question from Timan Yerenga. This one it's really hard to pronounce. So he's asking, how do you prevent feature flag code from polluting your regular code?
So here, the answer is very simple. We need to monitor that. We need to track. The rule that we have, for example, is we have a calendar, and we need to track basically how many feature flags do we have. And like I mentioned, more than 10 or 15 feature flags is just like impossible. So we have to pay back some feature flag before introducing new ones, right? We need to work strategically to not basically make the code fragile. So it's really like just managing how many changes do we have in the software in parallel.
Okay, makes sense. So, in last question from Anatolius Dubovikonas. Hopefully, sorry if I mispronounced your name. Have you ever accidentally sent emails to real users by copying production data to dev environment?
No, because everything is completely anonymized. So like I mentioned, when we pull the production data for the testing environments, we anonymize everything. Phone numbers, first name, last name, birth dates, everything is completely like random data. So it never happened to us in the case. The second aspect that we do is that I forgot to mention, we are also dynamically building a testing environment. Meaning, for example, we have our testing marketing platform endpoint. We have our testing gateway. And when I spin up this testing environment, he will never be able to work on the production endpoints, right? So we dynamically create an environment on our SaaS provider to manage the email, for example, and payments.
Okay, thank you. So that will be all. Thank you again, Ludovic, for your excellent talk. Give me a lot of pull-through ideas for my next way of coding. So thank you, and see you next year. Bye-bye.
Thank you very much.
Bye-bye.
Enjoy the rest of the conference, guys. Bye.
See you.